Hello, everyone. My name is Ella Scott, and today I will be discussing a scientific assay used by Dr. Christy Ainsley in lab at UNC Chapel Hill. This assay has to do with MSP2 adsorption, which quantifies how much MSP2 adsorbs to acetylated dextran microparticles compared to alum, which is a commonly used adjuvant in vaccines. To begin with, however, I would like to give a brief overview of the study at hand. Malaria is a major global health issue that can be very deadly, especially a specific strain called Plasmodium falciparum. Vaccines are critical for malaria prevention, and MSP2, which is a protein that connects to the malaria germ, can cause the malaria to get extremely strong in a person's body. Proteins themselves are very small and make sure that things in your body run smoothly, like repairing skin when you get a cut, carrying oxygen to your blood, and helping with digestion. When scientists make preventative methods, they utilize vaccines that can recognize the MSP2 protein and help your body recognize it and stop it from spreading. This helps us introduce what scientists are introducing into the malaria vaccines development. The assay or method that we are describing that the researchers are using is necessary to calculate how much of the MSP2 protein binds to the acetylated dextran microparticles, but we're going to shorten this and call them Ace-DEX MPs. You can think of these microparticles as a delivery truck of sorts, and the MSP2 protein is the package on the inside. These microparticles carry the MSP2 protein to your lymph nodes, which have to do with your immune system, to show your body this protein so that it can guard against the malaria germ. So now let's go step by step and talk about what exactly the scientists did. Firstly, the MSP2 was mixed with acetylated dextran MPs and alum, which is just an additive that scientists typically use in vaccines to fight off germs by showing your immune system the germ so that it can identify and fight it off. These different ingredients are mixed into phosphate buffered saline, and that helps keep the proteins and cells at balance so that they can be worked with. These are then incubated, and that just means that they were kept in a controlled and safe environment for 20 minutes so that they could achieve protein adsorption. This is just when a protein sticks to a surface without getting on the inside of it, like a magnet attaching to metal. After this, the samples were centrifuged or spun out to separate the particles from the liquid supernatant. This is just a clear liquid that sits on top of a mixture that has been centrifuged. You can think of this like sand and water. The sand is going to sink to the bottom of the glass while the water is going to remain on top. After this, scientists use a special chemical that stains proteins and other molecules. It almost acts as a magic marker that lights up when you find what you need to. Knowing this, we can talk about the results of the experiment. The Ace-DEX MPs, which are our delivery trucks that take our MSP2 proteins or our packages, show very promising results. Experiments show that these microparticles yielded consistent and robust immune responses compared to alum, which is what scientists typically use in vaccines to get the germ around the body. This shows us how important adsorption, which is protein sitting on a surface instead of going into something, is, as well as how the delivery system interacts with the body's immune system. To conclude, we explored many topics in this presentation. We know that scientists have found a way to develop better vaccines. They use biodegradable particles that we learned to be Ace-DEX MPs to teach the body's immune system how to fight malaria germs. These microparticles show your body what to do better than alum, which is what scientists originally used in vaccines that acted as the carriers of the MSP2 protein. With this vaccine, the body can now defend itself against malaria germs even better. Thank you.